In Statistics 1, you learn how to use these two formulas to calculate the mean and the variance, remember? If you studied this correctly, and I trust you did, you realize that this is actually very simple to use. I'm not going over that again. I'm just bringing this up for you to compare what you used last year with what you have to use this year when we are dealing with continuous random variables, okay? So let me put this, this word is kind of crazy today, but compare this with that and see how similar in its structure the expressions are. If you want to calculate the mean for a continuous random variable, you are now going to use integrals for the reasons I already explained in the first lesson. So this is going to be the expression. For you to calculate the variance, this is basically what you are going to use. And as you can see, you can relate this to that. So the structure of the questions that you are going to solve are similar, and the structure of the answers that you are going to provide is also similar. The difference being you are going to use functions and integrals this time. The questions that are going to follow are going to express this beautifully, more than words can say, on this theoretical lesson. Let's go a little bit down just to show you how to calculate the median and percentiles when you have a PDF. What is the median? The median, as you know, is the value that stands right in the middle of a given sample. So if you have here a PDF, the median is going to be this value over here. Is going to divide the PDF into equal sides. Half of the values are going to be to the left and half of the values are going to be to the right. In other words, this area over here is going to be 0.5. That area over there, B, is also going to be 0.5. In other words, the integral from a to m is going to be equal, of the function obviously, is going to be equal to the integral from m to b of the function, and that is 0.5. And with this statement, that is pretty obvious, you are going to be able to calculate several different things, for example, the value of m, or the value of a, or the value of b in different questions. The same approach can be used to calculate, for example, the 18th percentile. The 18th percentile is going to divide, again, the PDF into regions. One for which 80% of the values can be found, and above that, where 20% of the values can be found. So again, the probability that X is smaller than P is going to be 0.8. And this approach can be used to calculate either the value of P or the value of A. Well, now the question is going to take care of that, but the approach is just this. What about the mode? The mode is the value for which you have the highest probability. So in a PDF is going to correspond to this point over there. As you've learned last year in Pure Math 1, this point over here is the point for which the tangent is going to be equal to 0. In other words, it's going to be the point where the derivative of this function is going to be equal to 0. So all you have to do is to differentiate the PDF equally to 0, and you'll find the value of C. It's not common that you'll find questions about that, but if you do, that's the way for you to solve them. You are also going to find functions that are simple in nature, but they still require you to understand a couple of things. These are the rectangular distributions or the uniform distributions. They are basically contained, obviously, between two values a and b, and the probability between a and b for you to find any value is the same. In other words, this is going to be a straight horizontal line. The function is defined as something like this. The probability that x can be found between a and b is going to be this value. I'm going to explain why that value in a bit, and 0 otherwise. Now, why 1 over b minus a? as you know, the probability that the value of x is contained between a and b is 1. So you can use this to figure out how much that is, because if the probability is 1, it means that the area of this rectangle over here must be 1, right? And what is the area of a rectangle? Is base times height. Okay, so in other words, let me just put it over here. The probability of x being contained between a and b is 1, which is the area of the rectangle, that must be 1. And the area of the rectangle is the height times the base. And the base is what? Is b minus a. This must be 1, so the value of h is 1 over b minus a. And the value of h is basically the number that is going to be there. Don't forget that in a real life situation, that's going to be a number. Or it could be in an exercise a way for you to calculate either how much that is, or how much this is, or how much that is. Okay? How do you calculate the expectation when you have a uniform distribution? Obviously, the expectation is going to be the value here standing right at the middle of a and b. So basically a and b over 2. And the variance, the proof of that is in the textbook. If you are in a pro or ultra tier, you have access to the textbook and you can see the proof there. Not that you are going to be asked about this in an exam, but anyway, it's there. What you are going to be asked to do is to use this expression. So the variance is 1/12 of b minus a square, just as that, but plug it there and you have the value of the variance.